Okay, hi guys. So this is the last talk for JEEConf. We're tired? So the good thing when I'm tired is generally it's more entertaining because I say plenty of stupid jokes and stuff like that. So for those that still don't know me, because it's my second time at JEEConf, I've been to Java Days, I'm Nicolas Fränkel. Who knows about me already? Only you? Or I have to do the whole stuff, guys? No, that's not. Okay. So I'm developer, I'm architect, always doing Java, and yeah, around Java, around the Java ecosystem. I'm very deep into Spring. I love Spring. I've always been working as a consultant in different environments for different customers, in banking, insurance, public administration, retail. I'm also a teacher and trainer. I'm a book author. I'm a blogger. My first book is about the Vaadin web framework. Who still don't know about the Vaadin web framework? Oh, come on, guys. That's not serious. Okay. What? You use... great. 1 point. So, Vaadin is a web framework. You develop only in Java. You have object-oriented programming. It's event-driven development. Guys, check it. It's too good. And of course, my book is not so expensive. Sorry. My last book is about integration testing, so it's also very nice. Who doesn't do integration testing? Great. Who thinks that integration testing is too expensive and has many problems and all test breaks every Friday? Great. Buy the book. This is for you. This is really for you. Okay. So this talk is not about integration testing. It's about mutation testing. And of course, you know that there are many, many different kinds of testing. There is unit testing. There is integration testing. There is performance testing. There is load testing. There is penetration testing. Last time I checked, there was an article. They listed like 100 different types of testing. So there are many, many different. But the thing is, the only goal of testing in general is that they want to ensure that the production code is of the highest possible quality. So we are talking about the production code. And in this case, nobody cares about the testing code. Yeah. So my problem is, okay, I have everything is set, my unit testing, everything. How do I check that my testing code is good enough? And of course, when we have a problem, we already have a solution. And there is this very good metric called code coverage. Who knows about code coverage? Yeah, nearly everyone. Who already implements code coverage in his application? Okay. In the rest of this presentation, I will try to convince you that it has no return over investment. Oh, I'm moving too much. Oh, this is to block me from moving too much. Okay, I told you I was tired. Anyway, Wikipedia describes the code coverage as a measure used to describe the degree to which the source code of a program is tested. And that is crap. This is one of few times when Wikipedia just tells you crap. Why? How do you measure code coverage? Basically, you are creating your unit test, and afterwards, you execute the unit test, right? And then what happens? You check whether a source line is executed or not. This is line code coverage. You can do the same with branch code coverage. So basically, you have an if, and if you only test if the condition is true, then you have 50%. If you only test the false, it's 50%. If you test both, you have 100%. And if you test none, you have 0%. So the next slide is a little about math. So be very, very, very cautious. It's very complex. So basically, you list the number of lines which are executed, you list the number of lines total, you multiply by 100, and this is your line code coverage. Rocket science. You do the same for branch code coverage. And now, in Java, it's quite easy to do so. There are many tools where you can already compute your code coverage. Basically, you have the latest one is JEEConf by one of the members of the SonarQube team. But before you had Clover, was you had to pay for, and before JEEConf you had Cobertura, and basically all those tools compute very nicely the code coverage. So you know how to test your code coverage. And what is the target of code coverage? Who says 100%? Nobody says 100%. That's good. Who says 90%? Who says 80%? Okay. Who says 70%? Okay. 60%? Okay. For now, it's quite spread. 50%. 40%? Okay, below 30%. Okay, who said nothing? Okay, interesting. It depends, yeah, that's the consultant answer to most basic questions. It depends. Okay. Yeah, some people, and very respected people, such as Robert Martin, think that, yeah, of course, the objective and the only objective can be 100% code coverage. Because when you write a line of code, you can test it. It's not far from the truth. You can test it. So, really, the problem is, yeah, what does it mean, cost coverage? I will show you, in the next slide, 100% test coverage. I have 100% test coverage, guy. There is an add method, and I can prove you that I've got 100%. Ah, yeah, where is the assert? Oh man, I forgot about that, but what do we care? We've got 100% code coverage. So Bob Martin is happy, I'm happy, he's happy. Yeah, but basically my code is not so happy. So there is a real problem, guys. The problem is that the title of the slide is spreading over, but there is another problem. Yeah, if you take code coverage as the only measure of your code quality, it's not good at all. Because, you know, this is called metrics-driven management. When you set a metric to achieve an objective, then basically the metric becomes the objective. You don't care about the rest. So here, if we say, okay, in order to achieve the highest code testing quality possible, we set the code coverage, then two things will happen. Two things may happen, but two things will happen. The thing is, you might have external contractors who don't give a shit about your code. What they will do, and it happened to me, yeah, they will game the metrics. They will forget the asserts in order to achieve the objective you have set them. It can be 100%, but I was aware of that, so I said, okay, 60%, but I'm not sure they really asserted everything. Or it can also be by accident. You know, you can also forget some test cases. And in this case, code coverage is not a meaningful metric. Worse, you know, when you've got 100% code coverage, you think you are the chief of the universe, you are the boss. And of course, you have shown all your fellow programmers that yours is bigger than theirs. Because you have 100%, they only have 90%. Hey. And really, sometimes it becomes a contest of who has the best cost coverage. So the problem is not solved. you cannot be sure that code coverage ensures your test quality. Your test coverage, sorry to tell it so bluntly, but it doesn't mean squat. It's worthless. You can throw it away. You can remove it from your dashboard. It's of no use. So what do we do now? We go home. We are sad. No, because of course I'm also there to provide at least a little solution. This is called mutation testing. So I will take an example. So who knows about the X-Men movie? Great. And you know they are mutants, and they are the good people. Here it's a little different. So here is a evil guy in the movie. It's William Stryker. He wants to kill all mutants. But here it will be our original source code. And his son in the movie, Jason Stryker, who is a mutant actually, will be playing the role of the modified source code. So as a very simple example, if I have William Stryker and this is my math class with its add method, I will have the mutant which transforms the plus into a minus. So it's a mutation. Very, very simple. Even I can understand that. So with standard testing, you execute your test, and hopefully it returns green. This is good. With mutation testing, what you will do, you will create a mutation, so you will replace the plus by a minus, and you will check the results. And now there is a suspense, because there are two options. The first option is the test with the mutant fails, and it's good. And of course, if with the modified source code, the test still green, then there is a problem. So, when the tests fail, we say the mutant has been killed. So it's not at the in X-Men movie. The goal is to kill the mutants. So you have to be bad to kill the mutants. When the mutant survives, it's not good. If you pass the same tests with different source codes, and the test still passes, it's not good. So again, surviving is bad, killing is good. It's reverse. You just have to think about it. So if I take my add method and I want to test it, and here I forget the assert, so it's green, normal. Ah, what did I do? What happened? Oh my God. I killed the mutant. Yeah, I killed my slide too. Where was I? Oh, I'm so sorry. Okay. It doesn't work anymore. It's dead. Okay, so if I do the same with the mutants, now I execute the test, and of course, it's still green. So here, mutant surviving bad. Now, what will I do? I will add the assert. And then the test succeeds, because when I add 1 to 1, it returns 2, so it's good. And now, if I execute the same tests, but the mutant is minus, then it's red. So killing the mutant is good. So this is mutation testing. And this is very, very simple. There is nothing complex involved. Now, how can you do tomorrow? You already have mutation testing in Java. And there is a tool called pit test, pit. Okay? And this tool is available through a command line, through a non-target, who uses ant. Great. Oh. Okay, I didn't see you. Who uses Maven? Proudly. Yeah. Who uses Gradle? Not so proudly, please. No, you can't. Okay. Stop the bitching about Gradle. So how does it achieve that? Basically, it will apply what it calls mutators. So it will take your source code and it will apply different mutators to them in order to apply to get mutants. So as an example, and this is only an example, here is a nice table. And for example, you will notice that it will replace boundaries, strict boundaries by not strict boundaries. And it will also replace the lower than by lower or equals. It will reverse the conditional. It will remove the conditional completely. So you will always have true or always have false. It will replace plus by minus. It will replace times by divide. It will increment. It will decrement instead of increment and do the reverse. It will inverse some negative value. It will change constants. It will change the return value. Those are very interesting. It can also remove method calls. So if your method has side effects and they are not tested, it will complain. That is good. We'll see why just afterwards. It will remove method calls that are non-void and replace it with the default value. It will replace, it will remove constructor calls. So basically, it will just change your source code and repeat the same test. So two mutators are very important in my opinion. The first is a conditional boundary. I can assure you, and I will demo it just afterwards, then when you forgot to test a boundary, you might have 100% test coverage, but there is a bug waiting to happen, that's for sure. Void method calls are also very important. For example, if you want to assert in your method that you don't pass a null parameter, but then it's never tested. So everybody on the team knows about this, but then comes a newbie programmers. He removes it for some reason, because in his use case, he has to pass null, and the test will pass. But the production code will not let it pass. So testing this kind of stuff is very, very important. Also, what you want to test, and that might seem completely stupid, it equals an hash code. Why? Because when you generate them, probably they are right, because the IDE generates them right. But when your class, I don't know, is under maintenance, you might add fields, and then you forget about testing equals an hash code. Also, your production code may break. Of course, mutation testing is not completely foolproof. So it will return false positives. I'm not telling you that it will change your life, but still, it's a very, very useful tool. So now I think that I've talked enough, and I will hack something in front of you. So the first thing is IntelliJ. So here, I will create a new module. I will call it no-assert. You don't see? Good, that's a very good feedback, thanks. Generally speaking, people are waiting 10 minutes until they say, oh, we don't see, too bad. So you are still reactive after 2 days, that's great, thanks. Okay, now you are seeing, great. So I will create a new module and I will call it no-assert. I will call it no-assert. Yeah, IntelliJ is very good. I'm sorry. So, I don't know why also, but it doesn't understand that I want to have sources and tests. So I have to configure it again. Okay, I will create some package. And I will create my math method. So yes, I know there is a math method in Java. I'm stupid, but not so stupid. It's just for the sake of the demo. So I will create the add method, so which returns the sum of two integers. And now I'm counting on you to tell me if I made any bad stuff. No, it doesn't seem to. So now I will create my tests, and I will call it very without imagination math tests. And I forgot to create it into a package, which might be bad. Okay, now I will need to add, which did I use in my parent POM? It's testng. Testng is the best, so I will use testng. Up. So I don't need to set the version, it's set in the parent POM. So I will create my test, and I will say public void should return sum of two integers. So I create a new math. And I add 1 and 2. Let's change a little. Here I forgot to re-import. So now perhaps now it will tell me JUnits. You gotta love it. So hey guy, I re-import it. Sorry? Yeah, it's in the POM. But sometimes I don't know why it doesn't like it, so I will say testng.flaw. It's annotations. .star, yeah. Hey, that's not very funny, guys. You know, this was a very nice conference, and then, I don't know, the last talk is not so good. I don't know why. So, I see the tests. Okay, anyway, don't worry, everything. It's like when you do stunts, everything has a solution. So here I will MVN tests. It works, great. I will do something a little more different. I will now use the pit test mutation plugin. So now, and I don't have it in my history, so I have to find it out in my memory, which is not so great. So it's org pit tests, and I will check there, just to be sure. I don't have it there. No, it's here. Pit test Maven. So this one, and this is mutation coverage. No, what did I do? Yes. So now if I check, I've got a nice report. So if I go into the no assert stuff, target, and I will use pit reports, and presto. So now, for those of you who didn't believe me, I've got 100% test coverage. Now people sitting in the front row cannot frown like that. That means you need glasses. That bad. I also need glasses. But here I have 0% mutation coverage. Why? Yeah, because it tells me why. You know, he replaced addition with subtraction, and the mutant survived. He also did a different mutation, and the mutation also survived. So now you have a bulletproof way to check that no contractor of yours did something funny with your testing code. Now let's add an assert. I would be very happy to understand why it doesn't do what I ask him, because it would be much better if I had a working ID. So assert true. No, assert equals, sorry. So sum 3. Is it correct? Yes. Org test ng. Oh, here. ID internal error. Great. Thanks, guys. And now perhaps he might want to do something nice to me. Or not. Anyway, I don't care about it. Yeah, I might try, but not at this point. Here it tells me, yeah, okay. Anyway, I rerun the stuff, and I have a new report. I hope so. No, I don't hope so. Okay. So I will do it again. And I still have nothing. And that's a problem. Oh, yeah, I didn't compile. Sorry. So I have to compile the test again. I really am tired. Applause. Okay. And now, beyond a shadow of doubt, you know, I've proved you that in this case, I kill all my mutants. So without assert, it's bad. There are surviving mutants. With assert, it's good. I killed all the mutants. Now, this is when the contractor or your developer really wants to be sneaky. But it happens also that it can be used. It can be used when to just discover bugs that you were not aware of. So I will create something called. So I will create a pass filter. So I will create a very simple class. And yeah, I don't know why. Oh, it's not a module. Okay. Might have been the reason. It's not a module. Okay. Now I will create a package, again, the same package. And I will create my filter. So what my filter will do is, if the value is under a certain limit, it will let it pass. If it's above, it won't let it pass. I can initialize the limit with private final int limit. And normally, I can add the constructor parameter. And I will say that, OK, filters value. So I will return, let's say, value lower than limit. Correct? Correct. A filter. And I will create a package. And now I create my test, which is Java pass filter test. It's not Java pass filter test, it's just pass filter test. Now I hope I will get things right before method. No, again. Okay, anyway, protected void set up. I will create my pass filter, private pass filter. Here I will initialize a filter. And I will say, OK, let's use a limit. Private static final int limit equals 5, which is a good number. Oh, no, it must be 42, sorry. Every number must be 42. I will just copy-paste this stuff here. It seems it didn't understand it was a module anymore. I don't know why. Anyway, now I understand why it doesn't work. OK, add tests, and I will public void should pass under limit, and I will create, no, not yet. So I will have my filter, and I filter, this is limit -1, so under the limit. And here I'm expecting it to be true, right? Right? No feedback from the audience? Are you all sleepy already? No. No or yes? No? I don't know. I will use my test. You know, I'm doing should not pass over limits. I think it returned true when it was lower. Yeah, it's right. Okay. And here I assert false when it's over the limit. Good enough? It should work. Great. Sorry, louder please. There is a mistake in... I'm sorry, I don't understand. Yeah? Yeah? No, I don't see anything anymore now. Oh, thanks. Great. I'm sorry, I'm a little, yeah, let's say slow on the uptake. Okay, great, good. Ah, okay. Who said no? You. Okay. Yeah, of course, that's the point of the demo. Oh, I'm trying to play the role of the dumb developer. You are killing my effects, Dmitro. Okay. Good? Tibier pipiettes. So now, package, oh, it does, oh yeah, I forgot something very important in this case, is to add the dependency. That's very, very bad. Okay, now I run it again, and it should work. Yes. Finally. So I've got the limit stuff, and I will see my reports. And Dmitro told you before, but here I have still 100% code coverage. And oh, I forgot something. Yes, what did I forget? Yeah, I forget about it's very, very, very seen. It's seen very often. You didn't test the limit. You should always test the passing, the failing, and the limit. And of course, this is a very, very good way to check that you've tested the limit. So thanks, Dmitro. Should not pass when equal limit. So either you have Pete or you have Dmitro. Both are acceptable. Pete might be a little less expensive. Okay, so here I killed the mutant. Yeah, thanks. So some of you are following, that's great. Okay, of course, you see, I didn't configure too much. Basically, here I just configure for something that are not very interesting to you. So what I will show you right now is that you can do the same on a project of yours that is using Maven. And in this case, I will use Joda Money. Who knows about Joda Money? Great. Who knows about Joda Time? Great. Ah, better. So Joda Time is for time, that Joda Money is for money. The only difference is Joda Money has not been embedded into the JDK yet, and probably won't be. So I can do the same. And here, for some mysterious reason, I don't know why, but some classes don't work. Now here, it's not that it don't work. Aha. So I'm sorry, guys, I have to use your internet access. So please don't send me any tweets, anything on Skype. At least not something that cannot be seen in public. Yeah, it's your problem if you send me something. You also have your name on it. Okay, here I don't know why, but some classes are not taken. So I have to check my presentation again, because normally here I have the stuff that I want to exclude. Yeah, it's called preparation. And now it should work. So don't ask me why those classes don't pass, are not executed. I don't know. It's no big deal anyway. So of course, as you might see, it's taking a little time. And I must deny every responsibility for this kind of exception, for errors. Those are only Mac OS specific exceptions. I'm not responsible. Java is not responsible. Mutation testing is not responsible. Basically, it's Mac stuff. It's bad. Ooh. But I cannot do anything against it. It's just displaying stuff. So someone knows a joke while we are waiting? It's done. Oh, it's done. No need for a joke. Great. So now what we can do is just check the reports. And we can see, for example, that probably the people there, and it's not against the project, because probably they are doing a very good job, but they have 97% code coverage on one of the package. So they must be pretty proud of themselves. But in fact, it's only 78% of mutants who are killed. So it's not so good in the end. And we might check, for example, for... so we want to see what is killed. So we need to check for killed, for survived, sorry. So survived, there is none here. Here might be one, I think. So here, for example, here for some strange reason, it tells me that this line was not correctly tested. This one is very important. I told you about the check not null. So basically here, the check not null is not tested. So everyone probably on the project, all developers knows there is a check not null here, but then come some young developers, he has to pass null, he passes null, he's happy because he have a very high code coverage, and then poof, it fails. And here it's even worse, because they cannot even test their test in production. So it will be you, as customers, who will have this kind of bugs. So it's very dangerous. I will remove internet access. I don't like playing with fire. So what are the drawbacks of this kind of stuff? Basically, what we have seen is that it's very, very, very slow. Like it's sluggish, crawling. I don't know any more synonyms. But it's very slow. And I've done some kind of metrics. So on Joda Money, when I did my clean test compile, so I removed everything from target, and I test compile everything, okay? And then I changed two stuff. I only fired the showfire plugin, so only the phase which is executing the test, not the compiling before, and the pit test. And by doing showfire, it took me 2 seconds, and by doing pit test, it took me, about 25 more, which is a huge, very huge factor. So 1 order of magnitude. So why is it so slow? Yeah, you have to understand that it must analyze the test code, and for each class under test, you have to create a mutator. And for each mutator, you have to create a mutation. And for each mutation, you have to run the test, to analyze the result, and to aggregate the result afterwards. So there is no wonder it's very, very slow. Of course, there are workarounds. This is not acceptable because what I want is when I run my unit test, I want to have an immediate feedback. And yeah, if your unit test takes 10 seconds, I don't want to wait for 5 or 10 minutes until I got this feedback. So how can we do that? The first is we can restrict, we can constrain the mutators. So instead of applying every possible mutator, we can say, okay, I will only use this and this and this and this. We can also constrain the target classes. So some production code will be mutated and some production code won't be mutated. You can also restrict the tests themselves. So some tests will use mutation testing, some will not. We can also set the dependency distance. For example, if my test is using a dependency and this dependency will create a mutant, and here I'm sorry, but this arrow is not right. It shouldn't be there. But if this dependency uses a mutant 1, a mutant 2, sorry, and this dependency is using mutant 1, for example, this dependency has a direct distance of 1, where this one has a distance of 2. So we can restrict the dependency. And I don't know why my arrows and my bullets are not set in the right way, but just imagine. So basically, the closer you are to your mutant, you can restrict it, and after some distance, then you can stop mutating. It can be quite straightforward. So you can limit the dependency distance. You can limit the number of mutation, and in this case, I don't know about the order in which mutation will be applied, but you can check in the code probably. And also what you can do, there is, how much time is there still? Time master? 2 minutes. 2 minutes. So I won't talk about the mutation filter, but just to make you understand that you can extend it with extensions. So you can do some good stuff such as restricting bytecode, so in any way you like, what you mutation test. So I won't pass very easily on that. What I didn't show you also here, so it's a mutation filter, so no demo, sorry, is you can do it, you can send your metrics to Sonar. Who knows about SonarQube? Great, nearly everyone. So what you can do is instead of outputting HTML file, you can create an output XML file, and there is a plugin for Sonar where you can take your XML, send it to Sonar, it will be set in the dashboard of Sonar. Something very important, don't bind to the test phase. This is very cool, you know, oh, I will use Pit every time. Then, yeah, you cannot do that. So what you will probably end up doing is not bind it to the test phase, and instead having 2 different builds, for example, on your continuous integration server. What you can also do is to use only a fraction of the mutation coverage by not calling mutation coverage goal, but the SCM mutation coverage goal. So it will only mutation coverage what has been added since the last test. So, yeah, do use on continuous integration server, but use it like this. So, in conclusion, is mutations testing the silver bullet? I'm sorry, there is no silver bullet. Mutation testing won't help you in your partnership. It won't give you lots of money. It's just one tool among many others. First, it will check that any of your developers didn't try to do some tests just to increase the code coverage artificially, and it will point you out to potential bugs. Or remember, Dmitro can also do that very good. What it doesn't do, yeah, it won't validate the assembled application. You will have to use integration testing. It won't check the performance, and so on and so on. So it's just one more tool in your toolbox. You still have to use all the other kind of testing. Conclusion, testing is about return over investment. People who are telling you that you have to achieve 100% code coverage are not working in the real life, guys. Because your customer doesn't give a shit about the code itself. What he wants is features. So the tests are just for you. And it's your problem. So you want to maximize the return over investment. So first, prioritize, always run tests on business critical code and complex code. Then afterwards, you can increase it depending on your software factory shop. So it seems I've already 1 minute late. You can tweet me, you can follow me, you can follow my blog, you can buy my book about integration testing. Are there any questions on mutation testing? And you have, let's say, 2 questions. 1 question. 1 question. Oh, sorry, Dmitro. Oh, you already taught too much.
What other tools do you know about mutation testing? And probably you may suggest another.
PitTest is the only tool I found so far that really is useful in a production environment. All the other are not mature, not stable, not nothing. So I stopped looking, I just use this one. Okay, thank you very much.